Hey there everyone. So today we're going to cover an intriguing topic that I actually haven't seen discussed too often on YouTube so far. I've seen some detailed videos on the Kardashev scale and even made one myself, but today I want to focus on the specifics of what a galactic scale civilization would be like. Beyond just the fact that they've harnessed hundreds of billions of stars' worth of energy, what specific technologies would they use? What would the lives of their citizens be like? Also, what goals would they have? In this video, I hope to shed some light on these questions. So, in case you're not familiar with the Kardashev scale, I'll go over it really quick. In 1964, a Soviet astronomer named Nikolai Kardashev wanted to create a way to rank advanced civilizations based on how much energy they control. A Type 1 civilization on his scale can harness the entire energy output of a planet. A Type 2 civilization can control the entire energy output of a star, and a Type 3 civilization, which we are discussing today, has gone much farther. They have managed to capture and harness the energy output of an entire galaxy. They live off of the energy of hundreds of billions of stars. Such a civilization would be so advanced that we really don't have anything to compare them to. Human civilization on Earth has a way to go before it even reaches Type 1 on this scale. The reality would be so much different from ours that we can only speculate about what it might be like. Based on current trends, though, we can make some educated guesses on how a titanic, galactic scale civilization would actually operate. So, to start off, let's look at how large a Type 3 civilization would be in terms of pure scale. Of course, they would cover at least an entire galaxy. However, it is likely that they would reach quite a bit farther. Humans have yet to reach Type 1 on the Kardashev scale, and thus have yet to secure control over all of Earth's available energy. Yet, we are still starting to travel into space. 12 humans have walked on the moon, and our farthest two probes, Voyager 1 and 2, have passed the heliopause and exited our solar system. Clearly, our reach extends much farther than our grasp. Assuming that the same principle would apply for a Type 3 civilization, they would probably have numerous colonies stretching into several neighboring galaxies, and perhaps throughout their entire local group of galaxies. Our galaxy, the Milky Way, has around 400 billion stars. In total, then, a Type 3 civilization may have settled over 1 trillion star systems, probably several trillion, in fact. We don't know how many spacefaring civilizations there are in our galaxy, but there may very well be tens or hundreds. It all really depends on which values you use for the Drake equation, which is used to figure out how many technological civilizations exist in the cosmos. See, we don't have exact values for the equation. For example, we have no idea what percentage of life-bearing planets develop technological life. We can assume, though, that any civilization which has expanded across the entire galaxy would encounter any other spacefaring civilizations in it at some point, and they would be added in one way or another to the massive galactic civilization. Let's talk about energy for a bit. So, by definition, a Type 3 civilization can harness the entire energy output of a galaxy. How would anyone go about doing this? Take a Type 2 civilization as an example. The most commonly proposed method for a Type 2 civilization to capture the entire energy output of a star would be to simply construct a sphere around it to soak up all the energy. These kinds of star-surrounding spheres are called Dyson spheres. Now, how much energy would this sphere collect exactly? Our sun emits around 450 septillion, or 4.5 times 10 to the 26 watts of energy. The famous astronomer Carl Sagan proposed an alternative Kardashev scale where the wattage a civilization controlled mathematically determined their rank, where P is the power in watts and K is their ranking, which, I should clarify, doesn't have to be an exact integer value. Some algebra will tell us that type 2.0 on this logarithmic scale should control 10 to the power of 26 watts, which is closer to the output of an average star considering most stars are red dwarfs and are less luminous than our sun. A type 3 civilization should then control 10 to the power of 36 watts of power. And where does this come from? If a type 2 civilization builds a Dyson sphere around a single star, then a type 3 civilization would build them around every one of the hundreds of billions of stars in their galaxy, and voila, they'll have managed to harness virtually all of the energy in that galaxy. When you think of a Dyson sphere, though, you might envision a solid shell surrounding a star. This would almost certainly not be the case. There are no known materials which can withstand the gravitational forces that such a sphere would experience without completely falling apart. However, a Type 3 civilization might be able to produce some form of exotic matter which could. Even if they were able to do this, though, I'd still expect them to build a different and easier to handle type of sphere called a Dyson swarm around most of their stars. Dyson swarms are clouds of satellites like solar collectors or space habitats, which collectively capture a star's energy output. Imagine, though, there might be a few important star systems, and by a few, I mean a few thousand, where a Type 3 civilization would actually construct full Dyson shells. A rigid sphere surrounding a star would have on the order of hundreds of millions of times more land area than our Earth does. A Dyson shell which orbited a star at the same distance Earth orbits our Sun would be so large that driving all the way around it at highway speeds would take almost 2,000 years. If that land was terraformed, and given gravitation through some advanced artificial means, it could provide living space for quadrillions of people. And that's physical people, though I would expect most to be digitized at that point. We'll get to that in a bit, though. What other energy sources would a Type 3 civilization live off of? Well, besides the various types of stars, there are only a few other powerful energy sources in our galaxy. Supernovas are probably an advanced civilization's next best bet. A large supernova can outshine an entire galaxy at its peak, releasing quantities of energy that other stars would take millions or billions of years to release. A Type 3 civilization would undoubtedly be able to predict when a star was close to going supernova with high precision, as we can do with some precision now. The force of a supernova would blow a Dyson swarm apart, but if the civilization expanded the radius of a dying star's Dyson swarm by a large amount, then the amount of force from the explosion acting on the area covered by each unit in the swarm would be decreased. Expand the swarm enough, and it would be able to handle the force of a stellar explosion far more easily than it would nearer to the supernova. Black holes, surprisingly, also give off energy. It turns out that they do more than just suck in matter from the universe. Quantum physics predicts that pairs of particles randomly pop into existence near the event horizons of black holes. Then, they split apart, releasing energy, and one of the particles, from the black hole. This energy, discovered by Stephen Hawking, is called Hawking radiation, and all black holes emit it. However, the larger a black hole is, the less total radiation it emits, as the power radiated is proportional to the inverse square of a black hole's mass. In fact, the average stellar mass black hole would be almost completely useless to us in terms of energy emission. A civilization would need to artificially create small black holes, probably small enough to fit into your fridge, in order to get significant amounts of energy from them, which they might do. Using natural black holes for power, or black hole farming as it is called, would probably not be a major method of getting energy. That is, until trillions of years into the future when all of the stars die. With all of this energy from stars and supernovas at their disposal, a Kardashev 3 civilization would be able to create technology on an enormous scale. They would be able to create or destroy planets with ease, including rapidly terraforming them. Creating megastructures, which are astronomically sized constructs, would be commonplace for such a civilization. Aside from Dyson spheres, both the cloud-like Dyson swarms and rigid Dyson shells, a Type 3 civilization would construct a variety of other megastructures. One example is a ring world, which is essentially a gigantic ring orbiting a star that's habitable on its inner surface. With hundreds of billions or even trillions of star systems under their control, I would expect to see every type of megastructure ever conceived by us at present, and more, constructed thousands of times over throughout the galaxy. Modified Dyson swarms called Shakadov thrusters would be used to move entire star systems. Artificial planets would be built by nesting layers of spherical shells to support each other. Types of megastructures we haven't even thought up yet could be built between multiple star systems at the interstellar scale. A Type 3 civilization would also need a method of linking its vast holdings together. In other words, a transportation system. With the amount of energy they've harnessed, they could bend the fabric of space-time itself. They would be able to create Alcubierre drives, which allow spacecraft to travel faster than light. Rather, they'd alter space-time to transport an object from one place to another faster than light could make the same trip in flat, or non-warped space. Alcubierre warp drives contract the space in front of a spacecraft and expand the space behind it, effectively pushing the craft forward from behind and pulling it forward from the front at the same time. Instead of taking over 100,000 years to cross the galaxy, a warp drive would enable the trip to be made in far less time. An even more efficient way of linking a galactic civilization would be through building a wormhole network. An efficient network of these portals through space would allow a craft to travel between any two star systems in the galaxy in only a few jumps. It would be impractical, of course, to build wormholes between every possible combination of two systems in the galaxy. For the Milky Way, that would mean maintaining around 160 sextillion wormholes, which would no doubt be a daunting feat for even a Type 3 civilization. A star's energy is probably not enough to hold open the 400 billion wormholes that would be required for each star system. Instead, each solar system would ideally have a single wormhole, which led to a cluster of several wormholes, each leading to a nearby system. A single wormhole in this cluster would lead to a different cluster, containing wormholes which led to clusters in separate regions. This cluster would contain a single wormhole, which would lead to a different cluster containing connections to even larger and farther regions of the galaxy. Done efficiently enough, a system would only require a number of wormholes which is slightly more than the number of stars in the galaxy. Of course, a Type 3 civilization's wormhole network would likely extend beyond their home galaxy and into large portions of their local group of galaxies. Okay, so we know by now that a Type 3 civilization would have insanely advanced technology. But this is only half the story. We need to ask what ends a Kardashev 3 civilization would use their technology for. We already discussed this in part, but I want to focus now on what their economy and government would be like. A Type 3 civilization would have an economy based completely on matter and energy. According to string theory, different types of matter, specifically different particles, are the result of superstrings vibrating at different frequencies. A sufficiently advanced civilization would likely be able to manipulate these vibrational states at will, transmuting any one type of matter into another with ease, thanks to the massive amounts of energy they control and their powerful technology. Therefore, any sort of scarcity of one type of material would be eliminated. In our current economy, materials like gold and diamonds are valuable because they are rare and therefore take a lot of labor power to extract. If any type of matter, antimatter, or other currently unknown construct could be transmuted to another type at will, then these materials would no longer be rare. Not only would this lead to mass, and more importantly, the energy used to manipulate it, being the sole measures of value, but it would also probably lead to interstellar trade becoming mostly unnecessary. Colonists in a newly born star system containing mainly hydrogen and helium would not need to have iron shipped to them from another system, since they could simply suck some of the gas into a machine and have it create whatever element they wanted. The age-old dream of alchemy, transmuting elements into gold, would be a trivial feat. The only instance where I would expect to see significant interstellar trade would be if a truly enormous megastructure, like a particularly massive Dyson sphere, was being built in a system that didn't have much matter already in it. A Type 3 civilization, as we discussed, would more than likely be able to change one type of matter into another, but they wouldn't be able to create matter out of nothing. So in this case, they would need to transport some raw mass in from another star system via the wormhole network or warp-capable starships. This would of course be a very simple task for them. Now, what would the government of a Type 3 civilization look like? Can we even predict such a thing? I think we can predict the basic principles on which it would operate. You see, technological progress and societal progress are deeply linked. The more advanced the society's technology, the more accessible resources and commodities of all sorts are to the common citizenry. These can range from the basics like food and shelter to more abstract resources like education and social services. In our current society, human labor is required to produce all of these resources. Everyone, with few exceptions, does their part in producing some sort of good, and they exchange their piece of the pie they produced for other goods by the means of money. However, because of our technological level, most of the world's citizenry are still affected by high levels of scarcity, some of it materially based and other artificial due to the accumulation of wealth in the hands of an increasingly small group. When talking about our current technological level, it is important to note that the majority of people in our civilization do not share the living standards found in first world countries. According to the World Bank, nearly half the world's population lives on less than $5.50 a day, and according to the World Health Organization, around 30% lack clean drinking water at home. This is where a decent portion of our civilization is right now, which is something that many futurists fail to note. After all, we have yet to become a global civilization or reach Type 1 on the Kardashev scale. Because of scarcity, societies limit resources by various means, including money. Governments and private organizations enforce these limits. This, no doubt, gives rise to controversial methods of doing so. By the time a civilization reaches Type 3 status, these problems would long have been circumvented. In such a post-scarcity society, all production, distribution, and innovation would be automated by AI ranging from calculators to computers stretching across multiple star systems. The powerful ones wouldn't always even need to be conscious. It may very well be possible to program scientists, engineers, or artists who lack what we might call self-awareness. Of course, many AIs would be self-aware and thus treated as people like anyone else. Anyway, once the obligation to work a daily job ends, people would be free to pursue whatever creative, intellectual, athletic, or other sort of ambition they desire. Any type of class division would have long broken down, along with even the use of money. With virtually the entire economy being automated, the government of a Type 3 civilization would then be in charge of deciding how to distribute resources to the population. An organ of power representing the general populace regulating automated industries, I think it's safe to say, would be seen as far more democratic than private ownership by owners who have zero part in the production process apart from collecting the produce afterward. Enabled by instant communication technology and AI, the government could be as close to a direct democracy as practically possible. Citizens would set the general guidelines of policy, which are then implemented by specialized committees, subject to initiative, recall, and referendum. On economic matters, each individual would have equal voting power, since power to control the economy would not come from unevenly distributed currency. The same principle would apply to any other type of policy. When it comes to resource distribution, I envision a Type 3 civilization using some sort of extensive machine learning algorithm to accomplish it as efficiently as possible. A certain percentage of resources would be devoted to public projects like the construction of megastructures in the wormhole network. The rest would be divided roughly evenly among the citizens, and its value would be measured by the core of the post-scarcity economy, the amount of energy required to produce said resources. In a Kardashev 3 civilization, the immense resources available would mean that every individual's needs would be provided for, and more. All living beings are motivated by their deepest need, to survive and create favorable conditions for themselves. In other words, they want to find maximum happiness. To achieve this, the government of a Type 3 civilization could not distribute resources unequally based on how an individual spends their time. If they did, this would incentivize some occupations more than others, which makes it hard for those who favor less incentivized jobs to have both happiness and material security at the same time. However, in order to mask any sense of scarcity, algorithms could even allow a citizen to spend beyond their share one month by lowering their share the following month, and they would likely be able to predict when someone's spending would spike in this way quite well. After all, Google is already getting the hang of mapping consumer habits, and we don't even have sentient AI yet. Beyond this, the government would probably not need to have that large of a presence. Most conflict is caused by scarcity and the desire to overcome it, so I don't imagine violence being too common. It wouldn't be absent, of course, but I doubt it would be anywhere near as common as it is now relative to civilization's scope. Overall, the governmental and economic structure of a Type 3 civilization would already be in place around the time a civilization reaches Type 1 status and overcomes scarcity. After this, it would just grow larger and more complex as it becomes responsible for hundreds of billions of star systems and sextillions or septillions of sentient beings. So, with all this being said, let's lay out what your life would be like if you lived in a Kardashev Type 3 civilization. First of all, due to the advanced ability to manipulate matter, you would be able to take any physical form you wanted. You could resemble a human, cat, dog, bird, insect, or even a cloud of tiny particles. You could fly and shapeshift at will. In addition, you could simply digitize yourself and live inside a computer simulation, inside which you could experience anything that can be rendered on a computer. Not only would you be immortal, but you would be hyper-intelligent. Your mind itself would be upgraded to levels which we can't comprehend during the present day. Deep truths of the universe would lay themselves before your eyes. You could learn troves of information simply by uploading them to your brain. If you so desired, you could link your brain to vast supercomputer servers, some as large as planets or larger, to gain more computing power for solving complex problems. Being in a galactic civilization, you would have an immense number of choices in terms of where to live. By traveling in starships or through a wormhole network stretching millions of light years, you could move to any planet, moon, asteroid, Dyson sphere, ring world, or space habitat in your home galaxy, or many more across your local group of galaxies. Any possessions you would have would be moved with ease, as they would be digitally saved and deconstructed. The data would be sent digitally through microscopic wormholes, and the objects would be reconstructed at your destination. Any material good you desired could be constructed in your home universal constructor with ease, and you'd be free to pursue any career or pastime which brought you happiness. So if you lived in a Type 3 civilization with such a plethora of opportunities available to you, what would you do? Feel free to discuss this in the comment section. I would probably become a nomad and explore as much of the galaxy as possible, and maybe help colonize the frontiers of explored space. Considering the timescales through which a Type 3 civilization could survive, you probably wouldn't have to only select one option. So, I think that about does it for this video. I know that I tend to space my uploads out quite a bit, but I'm usually extremely busy with school and with life in general. I don't want to upload more frequently at the expense of video quality. However, I do of course plan to continue uploading videos, so if you like what you saw in this one, please drop a like down below and consider subscribing. I'd really appreciate it, and for those of you who already are subscribed, thanks for sticking by. You guys are awesome. With that, I'll sign off, and I'll see you all next time.